me talk a little bit about myself. My name is Ben Zimmer. I've been a LabVIEW programmer for almost 15 years now, but this is my first year being involved in the FIRST Robotics Competition. I'm a mentor, as mentioned, for Team 843, which is White Oak Secondary School in Oakville, and I've been working with that team since September. So we've done a lot. We spent a lot of time learning LabVIEW, getting up to speed, and I've been absolutely blown away with how the grade 9 through grade 12 students have taken to this whole competition and LabVIEW in general. Okay, so part of what I want to talk about today is why LabVIEW might be a good choice for you. But as you all know, also C++ is an option, and a lot of people have asked me which is better, which is worse, and we can talk about that at some stage as well. But again, back to myself, I've been a LabVIEW programmer for a really long time, working in the automation industry, making assembly lines, making end-of-test stations with robotics, motion, vision, all kinds of different combinations of sensors, and basically making decisions whether parts are good or bad before they ship. About 3 years ago, I left that industry and started teaching at Humber College in Toronto. So I teach a LabVIEW course there, I teach a digital signal processing course, and a couple others. So I've certainly been standing in both worlds, in the industry where we're actually using LabVIEW to do everyday tasks, and the academic world where people are trying to learn what to do and helping people get started. And when I started teaching at Humber 3 years ago, I started my own company, which is called Enable Training and Consulting, and we do LabVIEW training and we do LabVIEW contract programming. Okay, so that's how I got involved. I heard this summer that LabVIEW was going to be an option for all of the robotics teams, and I thought this is fantastic because, obviously I have a bias, I can make that very clear. I've been using LabVIEW for 15 years. I like it a lot. I think you will too, but I'm not here to sell you on LabVIEW. I'm here to help you with LabVIEW. And if you have a decision to make as to whether you use LabVIEW or C++, I will be happy to give you my opinion. What I want to talk about now is the full default code. The examples that are provided are all giving you little snippets of code, right? So the example we saw, which gave you the joystick indication on the XY graph, that's great. It shows you how to use a joystick, but that alone doesn't drive your robot. Okay, so there are default codes that have been provided, two frameworks. We're definitely going to talk about one. I hope we have time to talk about the other. One is the robot code, and the second is the dashboard code. Okay, so let me drive into that, and we're going to do some modifications that I'm going to do in front of you. One of the teams that came was helpful enough to bring a servo controller, and one of the students on one of the teams was helpful enough to remember how to make that work. So I'm going to show you how to do it from the software point of view, and we're going to make some modifications, other modifications to that code, so you can get a flavor on how to do that yourself. The other thing I'm going to do very quickly is show you the autonomous mode code that's been provided with the out-of-the-box software. And it's just relatively simple. It just does a couple things, but I need to show you a couple key points on how to activate it, and then where you're going to go to make modifications. Okay, before I get started, are there any questions? Okay, great. So I'll go back into LabVIEW. And before, when we accessed our example, we got it from the bottom right here. Here, if you're going to create a new robot project, you're actually going to do that from the New section. So we're going to do Create New Serio Robot Project. So it pops this up, and it asks you a couple questions. First question, important one, IP address. 9.7. And then your second choice is whether you want a basic or an advanced framework. We're going to just focus on the basic framework today. I invite you with the understanding that hopefully you'll get from this session today to poke around both and see the differences. They're both fairly well documented as far as what you need to modify and what you don't. But for now, we're just going to talk about the basic framework. So say Finish. If you have already previously created a robot project, it's going to warn you, do you want to overwrite it? Pay really close attention to that. If you've got several people working in parallel on the same computer, you may not want to choose the default project folder. If you do, you're going to run into this situation. This is okay because I know what I did before was not worth keeping. So we're going to do overwrite project, and it's going to configure the project for you. Okay. Once that's been configured, again, we get a project window. All of these VIs you're going to find underneath the Compact Rio target, right? Because that's where they're going to run. So there's a couple important ones. The basic robot main, that's the main robot program. Autonomous independent, that's another one. Okay? I'm going to make a general comment now. You should really only change the VIs that you see listed here. I'll tell you a little bit more about that in a second. So let's just open the basic robot main. Okay, so we've got a front panel which has only got one control on, called Enable Vision. We're going to push that to true. Everyone else hears the Christmas music? It's not just in my head? Okay, that's good. Actually, you know what? That's a great moment. There are a couple of extra USB ports on your driver's station. So I thought at some point I was going to do this, and I can't think of a better time.
We can't see that on the camera, though.
You can't see that on the camera? Well, that's terrible. All right, we can't have that. I need someone to stand here for the next hour.
Put it beside the speaker.
Okay. There we go. And also because I found this at Radio Shack yesterday. I know, sorry, The Source by Circuit City. I know that in the next probably 8 weeks, once 6 weeks start, you're going to be working at night, right? So why do I feel like Carrot Top here? Oh, it doesn't have enough juice to... Oh, wait, there's a switch. Okay. So there's that can be helpful if you're doing... This ends the prop comedy portion of the presentation, okay? So with that distraction out of the way, what we've got here, I should have done that while I was building the project, instead of saying ka-chunk. Anyway, so what we've got here is the basic robot main VI. There's a lot of stuff here, okay? And I hope that in a few weeks, once you guys have played with LabVIEW or not, you're going to, LabVIEW for a while, you're going to be able to look through this and understand what all of it is. But what I really want to convey right now is some things you should change and some things you should not. Okay? It's been designed as a framework. So what do you think that means when we say framework? Anybody? Think of a shelf, right, or a wall, right? There's a frame behind the scenes there, something that you don't really want to change. You can change the picture on your wall, but you really don't want to hit it with a sledgehammer every time. You want to leave the framework alone as much as possible until you fully understand it. And what you really want to change are the window dressing. Okay? So what we've got here are, in the center here, mostly the code that you want to change. And the outer things, such as the while loop and some of these case structures, which, as you spend a little more time navigating LabVIEW, you're going to understand all those concepts, which you don't really want to change too much. Okay? So the general rule is, if it's listed in the Project Explorer, go ahead and change it. If it's not listed in that top level, don't change it. Okay? So let's take a second and look through this code together. We've got a bunch of stuff on the left-hand side. What do we remember about stuff on the left-hand side with wires going into the outer while loop? That's input. That's going to run first. These are all the initialization things. So we see here that we've got the same USB 1 wired into this joystick open, just like we did in the previous example. We've got a watchdog timer. We've got, in this case, we've got an open 2 motors function. Right? So all this stuff is being initialized in this initial in this provided code. And then what do we have inside the code? Let's take a look inside the while loop. Well, you see 2 joystick get axes commands, right? Just like what you were using before. But they're being used to wire into an arcade drive function block. Okay? And this is set up for standard mode. So does anyone have any guesses what will happen when I try and run this? Right. How many joysticks is it looking at?
2.
You sure?
1.
1 joystick, 2 axes. And how many motors is it driving?
2.
Exactly. Which motors?
Left and right.
Left and right, but which PWM outputs?
1 and 2.
Exactly. So you can see that there. So the first thing, since we're talking about this now, the first thing that you might need to modify, depending on the configuration of your robot, is whether or not these guys are inverted. So imagine if you have a typical tank drive or a typical opposed motor configuration. Your motors are pointed in opposite directions. Right? To drive forward, this guy's got to go like this. To drive forward, this guy's got to go like that. That's why the default configuration has one of the motors inverted and one of them not. Everyone understand that? Also notice that the left motor is set to PWM1 and the right motor is set to PWM2.